Hey everyone, welcome back to my channel. Today we're going to solve the spiral matrix. We're given an n by n matrix. We need to return all elements in the spiral order, which means that we start from the top left element, which is 1, and we will go right to 2 and go right to 3. And different from our intuitive idea to start from the 4, we need to go down from the 3 to 6 and go down to 9. At 9, we will go left to 8 and go left to 7 and go up to 4 and go right to the 5. So basically, we cross out these elements, start from the outermost layer and shrink from the left and the right and the top and bottom to 5. So how are we going to efficiently solve this problem? As we can see in the problem statement, the key is to determine where to change the direction in the correct position. Like we need to go through the first row, and at the top right element, we need to go down. At the right bottom, to go left and go up. And shrink the boundary to have the matrix of 6 and 7. So the key is to shrink the boundary. In this way, we need to define 4 boundary variables, which is the left and the right. So the right I set out of a boundary of one element is because it will make the code a little bit easier. We will see how it be easy in the code section. So also we need to have the top and the bottom. So the bottom is the same idea as the right one. In this way, we can make the code easier. So our idea is to take outermost layer and shrink the boundary of the left, right, and top and bottom. So let's see how we're going to do this. So first, we start from the top left element, which is 1, and go right to 2, go right to 3, and go right to 4. So at the 4, we just reach the right boundary. We will update some boundary variables, which is the top one, because we go through every number in the top row. So we will move the top to the next row. Okay, so we will start from the next row, which is the 8. And we will, go down to 12. And because the 12 reaches the bottom boundary, and we have visited every element in the right column, so we will update the column information. So we can have the sequence number of every step. So as we first visit the first row, it will be number like 0.5, and we update the top boundary. It will be step 1, and we go down the right column. It can be number 1.5, and then we update the right boundary to -1. It should be the number 2. So then, because we visited every element in the right column, we will start from the 11. So 11 will keep going until the 9 element reaches the left boundary. So at this point, we have visited every number in the bottom row. So visit every number will be the 2.5 after updating the right boundary. At 9, we will update the boundary of the bottom, which will be the step 3. So at this point, we have visited all these numbers. Then we will visit the left column. So we will just have 5 to visit, and the boundary is here. The top boundary is here. So we shrink the matrix to just this row and all this column. After we visited the 5, it should be the number the 3.5, and then we can update the left boundary. It can be the step 4. So at this point, we shrink the boundary. I can change the color. Left, right, top, and the bottom. So in this scenario, we shrink our matrix to only keep the 6 and 7. So we will literally just conduct the same process to visit this shrink matrix. And we start from the top left, which is 6, and go right. And because 7 reaches the right boundary, we will shrink top boundary to the next row. So the T, the top, will be pointing the same position as the bottom. So this will be the condition that we end our iteration. If the top and the bottom point to the same position, or the left and the right point to the same position, we will denote that it's the end of iteration because we just finished all elements in the matrix. Okay, so basically if you understand what I'm saying in the drawing, it will be very intuitive to understand my code. So let's code it up. So we need to add the correct element into the result list to return. So first I will have a result list to contain the elements that should be returned. And also the key point of this problem is to set 4 boundaries to iteratively add the correct number into the result list. So we have the left and the right. So they're going to be 0 and the length of the matrix 0, which is the length of the column. Also, we have the top and bottom variable, which is going to be 0 and the length of the matrix. So the condition that we stop our iteration is the left pointer and the right pointer points to the same position, or the top and the bottom points to the same position. So the left should be always smaller than right, and top should be always smaller than the bottom. Okay, so first thing we're gonna do is to get every element in the first row. So we will traverse every element on the first row. The start number will be the left, and the end number should be right. One thing to be noticed is that I set the right to be the length of the matrix 0, which is out of the bound, but that's how Python work for the range function. Because if we have the like 0, the left is 0 and the right is 4, the I will just be from 0 to 3. So the 4 is exclusive of the range. So that's why I set the right to be the length of the matrix 0. What I'm gonna do is basically just append every element in this row into the result list. Then we will get every element in the right column. We should remember that if we go through every element in the first row, the top boundary should be at 1, which is going down 1 row to update the boundary. Then for the right column, basically the same thing. So we will go through from the top, which is updated, to the next row, and the end will be the bottom. So the boundary is the same thing as the right boundary. It was just 1 row outer the matrix to make sure that we have a simple code to implement. So the row should be the I, and the column should be the right -1. After we go through every number in the right column, we will update the right boundary to -1. So remember, if we have a example of like a list of like 1, 2, 3, it's just a row of the matrix. So before we go through the like the bottom and the left column, we will just end our iteration. So we will have a condition here. It's basically the same as the while loop condition. It's just like a early stop before we execute the following code. So we will get every element in the bottom row. It's a little bit complex than previous loop because we need to have to traverse from the end to start, which is from the right to left. We need to watch out that the left should be -1 because it should be like out of the matrix to make sure that we can go through every number in the matrix. And the step should be -1 to make sure that we from the right to left. So the row should be the bottom -1 because the bottom has not been updated yet. And the row should be the I. And then after we go through every element in the bottom row, we can update the bottom to -1. Then last step, we will get every element in the left column. So we will start from the bottom and end at the top -1, which is the same idea like this left -1 to make it out of bound to make sure that we can go through every row. Then append every row of the left column. Then left at 1. Then basically we end our iteration and we will return our result. We can see there is an error that we have a repeated 9 and 7. Bottom right number and the left bottom number. So when we go through the right column, we from the top to bottom, so the 9 has been added into the result. So here we need to make the right -1 to start from the 8, and same idea here. We need to start from the bottom -1 because we have go through the 7 in the previous bottom row. So let's see how it works. Okay, perfect. We passed the test and we submit our code. Okay, so it's very efficient. It beats just totally 100 users. It's not bad. So there are some like easier, syntax to write the code, but I think to break down every details here can make sure that we know how this spiral works, and it's more intuitive to improve or make it more sense.